Welcome to this launch event session on what's new in data search improvement, particularly targeting developers. My name is Jens Møller Petersen, and I'm an engineering manager in the Business Central team. First, what is modern search? Well, in this release, we have added a method to search for all words rather than any substring in a word. It's a significantly faster way of searching, and it also tends to match more what you've gotten to expect from other search engines. And this new search mechanism applies to page search, lookup, and company-wide search. The way you enable your data to be searched using modern search is that you use the new property optimized for text search equals true on your table fields. You can put it on your table fields, or you can put it on your table extension fields. You would want to add this to the following types of fields: the primary key fields, descriptive text fields that uniquely describes this item, or other fields identifying the row, which could be a name or something. And generally, you should add this to fields that the users want to find, not to fields where there are thousands of them or where it's a grouping mechanism. So let's take a look at how this actually looks in the product. First, you may want to check that you actually have this feature enabled. You do that in Feature Management. And in here you can see this line, Use Optimized Text Search in Lists. And in this case, it is enabled. All right, so with this enabled, let's take a look at how it works. So if I go to Items, and in this case, I have filled up the database with 500,000 random items to actually see the performance difference between the two. So if I look for beans roasted, notice the speed, and also note that the ordering of words doesn't matter. So now it has found all the whole roasted beans or Colombia. Now, if we were to do this, or if I want to find for Brazil, it finds it. Now the user can switch between the two types of search because you can enable legacy search. And now it actually takes a while because now it actually tries to search. I just want to do that again. And it actually doesn't find it in this case because there was a comma between beans and Brazil. So in order to find it using legacy search, you would need to actually type the comma. So there is a performance difference. Where I would expect users to feel this the most is in sales orders. If I go down to a sales order down here, and I now need to type in an item, I'm just going to delete the existing item. And first I'm going to try using legacy search. So now I'm going to type beans, Brazil. And you can see it takes a little while. You actually get the spinning wheel, you still have the spinning wheel, and now it has found it. Now let's try the same thing with modern search. I'm just going to delete this. And now I'm going to type again, beans, Brazil. And you can see that it's a lot faster. Now, you might have some users who are used to typing in parts of an ID. I know that in this data set, there is a button, which is SP-BOM 1303. And there might be users that are used to just typing 1303. So we've actually made it possible to switch directly by using the star 1303. This will search in the legacy way, so it is a bit slower, but it will actually find the SP-BOM 1303. A third place where you can see modern search in action is when you search company data. If I go for beans Brazil and I search company data, it has already found these items because it uses the new modern search. But also here, you can type a star to actually get the old behavior, and I need to start the search. And that takes a little longer, and it actually also found some customers with 1303. The modern search is enabled in page search when the table has optimized for text search fields. And the user can select the behavior using the drop-down or by typing star. Modern search also shows up in lookup if the table has optimized for text search fields. And again, the user can select, and this time using the cogwheel in the lookup page or by typing star. And modern search is enabled when you search in company data, where it will use modern search for fields with optimized for text search. But if you include fields which are not part of the text search index, then you will still get the other behavior, the existing behavior, and unfortunately also the existing performance. Again, you can use the contain search by typing the star. Under the hood, what happens is that the synchronization engine, which updates the SQL schema, will generate a full text search index and regenerate it whenever the list of indexed fields change. It'll create one index per table with indexed fields. We are creating this as a neutral language index, meaning we only have the standard word breakers, for instance, space and dash, so it is not language dependent. If you want to know more about how full text search works in general, you can see the link here at the bottom, which is a link to the documentation for full text search in SQL. Now you might wonder why this is so much faster. Well, the legacy search does a case insensitive contain search. So it basically makes it impossible for SQL Server to use indexes. So it always requires you to read the full table or the full index to find it. And you will have seen this in long-running queries telemetry, where you see queries with collate statements, which normally comes from the page search functionality. The modern search, on the other hand, builds an index on every word. And now you have an indexed lookup into those words. And in general, index lookups are just an order of magnitude faster. Now, it's not only in the UI that you can make use of modern search. You can also use it on the record API. It is built into the setFilter method, so you can now use the new operator and for calling setFilter. There is an example down here, fieldref.setFilter and search string star. It will find a matching word. If you want to find a beginning of a word, you add a wildcard at the end, the star, which has been done here. If the field you're searching is not one of those which have optimized for text search equals true, then it'll revert back to the existing behavior using case-insensitive contain search, which you can see the syntax for here. Now, if you want to see how this syntax actually looks, let's take a look at the product again. In order to see the syntax of setFilter, you can make use of the page inspection pane. Over here, you can see the page filters, and you can see the filters that the UI actually applies when you use the page search. If I type beans here, you can see over here that the filter term on the number field and the description field is and beans star, as we talked about before. And if I do beans Brazil, then you can now see the double and then there's an and in between, and the double and with both beans and Brazil. So it can get a little involved, but this is a good way to play around to actually see the actual syntax. There are some considerations when you use the double AND filter operator for using the text search. First of all, the syntax can be a little hard to grasp. You saw the trick with using the page inspector to show the generated filters. You can see samples of the code in the data search in table code unit. The scenarios where you want to use this would be where you implement specific features for helping the user finding elements. You would normally avoid using this for explicit business logic, where you're better off using existing equals filters, etc. Also because the behavior here changes based on whether the user has enabled this modern search and also on whether the field has been optimized for text search. With that, I hope you'll get a lot of fun out of the modern search and that your customers will be happy with the improved performance. Thank you.